Hi, my name is Kate, and today I'll be introducing synthetic and long division for polynomials. X squared minus 6x plus 4, all divided by x plus 1. For long division, you'll start with writing your dividend under a long box. And then you'll write your divisor or the second number on the outside. But make sure to place a 0 in place of a term that's skipped, if there was one, for your dividend. Just like regular long division, you'll be dividing, multiplying, subtracting, and bringing down. But you'll only be dividing by the first term of your divisor. Since x goes into x squared x times, you'll divide it there and multiply it by each term. Then you subtract so these cancel out and bring down this. Next, you'll keep doing that, and since it goes in -7 times, you'll multiply it by each term and subtract again. You stop dividing when your number down here is of a less degree than your divisor. And then that will be your remainder, and you put it over your divisor, add it to your quotient. So this is your result. If you use synthetic division, you'll write each coefficient of your dividend above a long L. And then you'll write whatever x value makes your divisor 0 on the left side. You'll bring down your first coefficient and multiply it by the number on the outside. Then you add, multiply, and add again until you get your last number. This will be over your divisor again and added to the quotient. As you can see, these two are the same result. Our next problem will be factoring a function of f of x equals x to the 4th plus x cubed minus 11x squared minus 9x plus 18. So we'll want to use synthetic division for this since it's a lot quicker and it's usually used for factoring functions of a larger degree. But before we start plugging in random numbers, you can find out possible ones by doing plus or minus constant factors, divided by plus or minus your first coefficient factors. In this case, it would be plus or minus 1, 2, 3, 6, 9, or 18 divided by plus or minus 1. But since it's just 1, it'll result in just the top. So we can start with 1 and listing all of our coefficients. You'll bring down your first one and multiply, then add, multiply by the left number again, add and keep going until you get your last number here. Since it's a 0, this is a root of the function. Now you'll use these numbers that you got from before and try something like -1. You'll bring down, multiply, add, multiply, and keep doing this again until you get this. But since this is not 0, but it's close, you'll try with these top numbers again, something close to -1, like -2. Bring it down, multiply by -2, add, multiply, add, and multiply. And then when you finally add, it's 0, so this is another root of the function. Now you stop using synthetic division when you find that it's factored enough to factor normally. So this would be -9 plus 0x, which you don't need to write, plus x squared, which factors to x plus 3 times x minus 3. And then you'll multiply by your other factors of the function, which was 1, so x minus 1, since 1 minus 1 is 0, and x plus 2, since negative 2 plus 2 is 0. And you set it all equal to f of x. This is your fully factored form of this function. Clearly, synthetic division is a lot quicker once you get used to it, and it can be used for factoring with rational zeros or dividing by linear functions. But long division is useful because you can use it when you're dividing with a divisor of a degree larger than 1. And that was an introduction to long and synthetic division with polynomials.